Chemical reactions, a process which involves combination of certain substances to form new substances, is called a chemical reaction. Reactions are usually represented by equations as given below. A plus B gives C plus D. Here, the starting materials A and B combine together to form C and D. Here, A and B are known as reactants and C and D are known as products. And this mode of representation of a chemical reaction is known as a chemical equation. Chemical reactions are characterized by chemical changes and yield one or more products which are different from the reactants. Chemical reactions usually involve changes which involve the motion of electrons in the forming and breaking of chemical bonds. The general concept of a chemical reaction, in particular the notion of a chemical equation, is applicable to transformations of elementary particles as well as nuclear reactions. Many different chemical reactions are used in combinations in chemical synthesis in order to get a desired product. In biochemistry, series of chemical reactions form metabolic pathways since straight synthesis of a product would be energetically impossible in conditions within a cell. Some of the important types of chemical reactions are given below. Chemical reactions may be classified in different ways depending on the particular aspect considered for elaborating the division or on the branch of chemistry which the classification originates from. Some examples of widely used terms for describing common kinds of reactions are isomerisation. In this, a chemical compound undergoes a structural rearrangement without any change in its net atomic composition. Direct combination. Two or more chemical elements or compounds unite to form a more complex product. N2 plus 3H2 gives 2NH3. Chemical decomposition. In it, a compound is decomposed into smaller compounds or elements. 2H2O gives 2H2 plus O2. Single displacement or substitution. It involves displacement of an element from a compound by a more reactive element. 2Na plus 2HCl gives 2NaCl plus H2. Double displacement or coupling substitution. Here, two compounds in aqueous solution, usually ionic, exchange elements or ions to form different compounds. NaCl plus AgNO3 gives NaNO3 plus AgCl. Combustion. In this, any combustible substance combines with an oxidizing element, usually oxygen, to generate heat and form oxidized products. The term combustion is used usually only when large-scale oxidation of whole molecules are involved. That is, a controlled oxidation of a single functional group is not combustion. C10H8 plus 12O2 gives 10CO2 plus 4H2O. CH2S plus 6F2 gives CF4 plus 2HF plus SF6. Some branches of chemistry include any minor changes in chemical conformation in the reaction types, while others consider these changes merely as physical properties of a compound. A chemical reaction may require 3 or more reagents, but the process can generally be decomposed into a stepwise series or a set of stepwise reactions of the above. The large diversity of chemical reactions makes it difficult to establish simple criteria for functional as opposed to mechanistic classification. However, some kinds of reactions have similarities which make it possible to define some larger groups. A few examples are: organic reactions encompass several different kinds of reactions involving compounds which have carbon as the main element in their molecular structure. These reactions occur mostly according to, within, by, or via functional groups. Petrochemical reactions are often distinguished from other organic reactions. Redox reactions involve augmenting or decreasing the electrons associated with a particular atom according to its oxidation number. Combustion, in which a substance reacts with an oxidizing element such as oxygen gas. Reactions are also classified according to their mechanism. Reactions of ions, example, disproportionation of hypochlorite. Reactions with reactive ionic intermediates, example, reactions of enolates. Radical reactions, example, combustion at high temperature. Reactions of carbenes. Then there are the endothermic and exothermic reactions which are accompanied by absorption and release of heat. Every chemical reaction is, in theory, reversible. A reaction is divided into a forward reaction and a backward reaction. In a forward reaction, the substances defined as reactants are converted to products. In a reverse reaction, products are converted into reactants. Chemical equilibrium is the state in which the forward and reverse reaction rates are equal, thus preserving the amount of reactants and products. However, a reaction in equilibrium can be driven in the forward or reverse direction. This is done by changing the reaction conditions such as temperature or pressure. A principle known as Le Chatelier's principle can be used to predict whether products or reactants will be formed. Although all reactions are reversible to some extent, some reactions can be classified as irreversible. An irreversible reaction is one that goes to completion. This phrase means that nearly all of the reactants are used to form products. These reactions are very difficult to reverse even under extreme conditions.